Noting here in the past, U substitution or integration by substitution is opposite to differentiating by the chain rule. Now, integrating by parts is opposite to differentiating by the product rule. Let's show that. So here, the product rule says d of dx of u of x multiplied by the function v of x, which is 2 multiply function, their derivative gonna be equal to the derivative of the first multiplied by the second function plus the first function multiplied by the derivative of the second function, and that is the product rule. The product rule also written as d of u over dx of v of x and then u of x, and then v prime can be written as dv over dx. Now we can think as the next step is I'm gonna multiply the both sides by dx. So the left side gonna be equal to d of u and v, so I remove also the x, and then we have du multiplied by v and then a plus u multiplied by dv. Now I'm gonna integrate. I'm gonna use the integer operator. So the first term in here gonna just be equal to u multiplied by v, and the second term gonna be v, so I'm gonna bring v in the front and then du, and then the integral of the second term, which is the integral of u dv. Note here, the integration by parts problems, we are given an integral. So we can solve for this one or this one. I choose to solve for this one. So this integral, which is the integral of u dv equal to uv and then minus this part in here, v du. And that's what we're gonna use to solve the problem of integration by parts. The first step is to find what's u and then dv, and then we want to find du and v and plug that into this formula in here, and that's the integration by parts. Note in here, we want to integrate this function, the integral of x e to the x dx. First, let's use u substitution in here. Let's see if that works. So I'm gonna set u equal to x, and then du gonna be equal to dx. Now, the top integral, which is the integral of x e to the x dx, equal to u, and then e to the u, and then dx is just du. Notice in here, this is exactly the same as the integral on the top. Here the variable is u, and here the variable is x. So we don't use the u substitution here because it's useless. So now let's use integration by parts. So here, what I'm gonna choose u to be x, and then e of x dx gonna be equal to dv. So remember, what we have as integration by part, it's u of dv equal to uv, then minus of the integral of v du. Again, u here equal to x, and then dv equal to e of x dx. Now we want to find du and v. So du going to be here equal to dx. So v going to be equal to the integral of dv. That's just a definition. So that gonna be equal to dv, which is e to the x dx. Now what's the integral of that? It's gonna just be e to the x. Now we have all what we need. So now let's use the integration by substitution. This is going to be equal to u, which is x, and then v, which is e to the x, then minus the integral of v, which is e to the x, and then du, which is here gonna be dx. So for the next step, I'm going to solve for this integral. This is going to be equal to x e to the x minus the antiderivative of e to the x, which is e to the x, and then plus c. Here, notice here we have common terms, so I'm going to factor these. Going to be e to the x, then x minus 1 plus c. And that is our antiderivative for the given integral on the top.